Hello everyone. In this video, we are going to be discussing the fundamentals of DynamoDB, what are the different options in DynamoDB, and what are the pros and cons of DynamoDB, and we are going to go in details regarding all the options and all the settings of DynamoDB. So let's get started. DynamoDB is a NoSQL database technology. It is created by Amazon and it is renowned for its high performance as opposed to different relational databases like MySQL, SQL Server. It is a NoSQL database and it stores all the data in the form of JSON. It stores the data in JSON and retrieves the data in JSON, and it is very efficient. DynamoDB is utilized in variety of different applications. It can be mobile application, gaming, or like fintech application, or I have seen like a lot of people using it in messaging application. So because it is very fast, it is very efficient. The list of features of DynamoDBs are as follows. The point number one is DynamoDB replicates the data across three availability zones in a given region. So it utilizes SSD to store three copies of your data in case a server goes down, and it can be a case that one copy of your data is down, but you have like two other copies of your data. So DynamoDB automatically use the other copy and you can still use your data and you do not suffer any data loss. So point number two is table are comprised of rows which are referred as items, and each item is made up of different attributes which are displayed as columns. So basically it stores data in the form of JSON documents. And then the point number three is DynamoDB can be infinitely scaled for read and write input and output operations. Point number four is data stored in DynamoDB can be securely backed up to S3 bucket for long-term usage, and it is a very cost-effective storage, S3, as compared to DynamoDB. So if you think that this data is no longer needed, but I need a copy of it, you can just back up the data using S3. And then the point number five is you can integrate DynamoDB with different AWS services such as machine learning services, Elastic MapReduce, Amazon EMR, Data Pipeline, and Kinesis, and so on. The sixth point is the pricing model of DynamoDB is pay per use, meaning that customer will pay only for the hardware and services they actually use rather than paying for resources they do not actually use. So it is not the case that you have set up an instance of DynamoDB and you are paying like $100 a month. You will only pay the amount based on the read and write you have utilized from DynamoDB. So point number seven is security and access control can be managed using the AWS Identity and Access Management Service, IAM service. So this service helps to create and manage users groups and permissions to control access to AWS resources. So for those who are looking for like enterprise grade features like SLA, monitoring tools, a private VPN, and so DynamoDB is basically built for the enterprise use and it has all the industry standards and operations already applied. So what are the data types in DynamoDB? So DynamoDB supports the following types of data types. So the first one is scalar. In scalar, we have number. It can include both integer and floating point. We also have string, and then we have binary data. Then we have Boolean and null. In the form of documents, we have two different options: list. DynamoDB list data type is a data type that allow users to store an ordered collection of item similar to an array. And map, the second type in document is map. DynamoDB map data type is unordered collection of key value pairs that can be used to store and retrieve data. And then the third main category is multi-valued. So in multi-valued, we have string set. String set basically means that you have an array in which you have like different strings. And then you have a number set. It's an array of different sort of numbers. It can be positive, it can be negative. And then you have a binary set. It is an array of binary numbers. Moving forward to DynamoDB table structure. In DynamoDB, we have like partition key and a sort key. So let's discuss the partition key first. A partition key is also known as hash because it is the primary key for identifying the items in a table. The partition key is used as input to an internal hash function, which determines in which physical partition the item will be stored. All items in a table with a partition key must have unique value for the partition key. It is just like a primary key. If you are familiar with MySQL or any other database, so primary key basically is used to group the data internally in the database. And if you query on primary key, obviously it will only scan that particular document. It will not scan all the documents. So in DynamoDB, we have partition key. Partition key and sort key are also referred to as composite primary key because they are composed of two different attributes. The sort key is used to order the data in that particular partition. And when we are also fetching the data, we can sort the data based on this sort key. Possible for two items to have the same partition key value, but they must have a different sort key value. In a table with a composite primary key, you can access any item directly by providing the respective partition and sort key values. A composite primary key provide additional flexibility when querying data. For example, if you supply only the partition key value, DynamoDB will retrieve all the items with that key. You can also provide a value for the partition key and a range of values for the sort key to retrieve a subset of items with the same partition key. For example, a table of movies may have a composite key composed of producer and title. So you can access any movie in the table directly by providing the producer and title value for that item. You can also use producer value and a range of values for title, retrieving a subset of movies of that author. So you can like use both these keys, and it provides you more flexibility in terms of querying. So moving forward to secondary index. There are two different type of indexes used in DynamoDB. One is LSI, local secondary index. So what is LSI? It supports strongly and eventual consistent read. So it can only be created with the base table and cannot be modified or deleted unless you want to delete the table. So, and it is only composite, and the maximum size of that is 10 GB per partition, and it has a shared capacity units with the base table. It is a bit complex, but I will explain you in the coming sections. And it must have the same partition key as the base table. So when you are defining LSI, you can specify that you want strongly consistent read or eventual consistent read. You can also you can create that LSI along when you are creating a table, and you cannot modify it. Okay, and it is like a composite key. It has like a maximum limit of 10 GB per partition, and if it is more than 10 GB, then you need to have like multiple partitions. And it also share the capacity units with the base table, because in DynamoDB all the things is measured in units, so it shared the units with base table, and it must have the same partition key as the base table. Moving to GSI, global secondary index, it offers only eventual consistent read, but can create, modify, or delete at any time. So it is not important that once a GSI global secondary index is created, you cannot delete it. You can delete it, you can modify it, but it only support eventual consistent read. I will get to that in a bit, like what is eventual consistent read and what is strongly consistent read. It supports both simple and composite key. It's not mandatory to have only composite keys, and it can have any attributes such as primary key or secondary key or there is no size restriction per partition when you're using GSI, and it has its own capacity setting. It is not being shared with the base table. Now we will discuss about the DynamoDB reads and writes consistency. Okay, so DynamoDB can be configured to provide either eventually consistent reads, it is by default, or strongly consistent reads on per call basis. Eventually consistent reads may not be consistent, but it will be available immediately. Generally the data copy should be become consistent within like 1 second. And then we have like strongly consistent read, like it guarantees that the data read operation will always return the most up to date version of the data, as it is always reading from the leader partition. This ensures that the data is never missed, although the latency may be higher than with other methods. I summarize that in simpler terms. You have like one option in which there is like 1 second latency, that it might be the case that there is a new record inserted, but and you, after the new record is inserted, you fetch the data, but that latest record is not in your list of data, because there is like a 1 or 2 second delay in eventual consistent read. But in strongly consistent read, it guarantees that whatever data there is in the leader partition, you can fetch that. It is not the case that any data is left behind. So you can specify based on your application you are building, that you need eventually consistent reads or strongly consistent reads. So because in some scenarios, like it is not important, like if there is like a 1 or 2 second lags in the data, it is not a big issue. So in terms of like e-commerce system, you need to show orders in admin panel or to vendors. So if there is like 1 or 2 second delay, then I think there's no issue. But in some cases, like for instance, like you're showing data of forex, or you are showing data of something that is like very critical, and in that case you cannot have like eventually consistent read. So you have to brainstorm like what option is best for you. So now we will discuss about the capacity modes. So the first mode is provisioned. In the provision mode, like we specify the read and write from a particular table or an index. It is best suited for application that have predictable and steady traffic, and you can measure them using read capacity units and write capacity units. And it is per second, like you have like 3 or 4 reads per second, or like one write per second. You can basically configure your table in DynamoDB based on that. Auto scaling with provision capacity mode should be enabled. This setting allows you to set a minimum and maximum capacity for a DynamoDB table. DynamoDB will automatically adjust the capacity between these values and will throttle calls that exceed the maximum capacity for an extended period of time. If you make requests that exceeds the capacity has been provisioned for you, you will get an exception. Like for instance, you have like the capacity specified that you can only fetch like 10 per second, right? RCU is 10. So if you're fetching like 30, so after 10 it will start throwing error. Then like throttling occurs when requests are blocked because of the frequency of read and write is higher than the threshold that have been set. For example, this can happen if you exceed the provision capacity, if the partition are splitting, or if there's a mismatch between the capacity of a table or index. The next capacity mode is on demand. So on demand capacity is pay per request service. You're not specifying like I need this much RCU, like read capacity unit, and this much write capacity unit. You just like start adding data and reading data, and like based on your usage you will be billed. So the throughput is only limited by a default upper limit for a table up to 40K RCU and 40,000 write capacity unit per second. So it is a lot, like 40,000 like read and write capacity unit is a lot. So in this, like you do not need to specify any settings and stuff like that. However, like if the maximum threshold is reached, and then like the throttling error may occur. And in some cases like this on demand provisioning can be costly, because then you do not know like the amount of bill that you will be getting at the end of the month, because it can be a case that due to some error or someone like exploiting your application, they can do a lot of read and write, and you get like a lot of big bill from DynamoDB. So you have to like I would suggest like you can specify the read and write, and you can specify the range as well, like this is the minimum, this is the maximum, rather than going for on demand. But if you're just starting up, then on demand is also a good option. Now we will discuss about like calculating read and write capacity units. A read capacity unit is equivalent to one strong consistent read per second, or two eventually consistent reads per second of an item of up to 4 KB in size. RCU for strongly consistent reads are defined below. You can see like 3 points, like round the data by nearest 4, divide the data by 4, multiply the result by number of reads. So let me explain that. Like if you have let's suppose a document that you want to read, it's the size of that particular JSON document is like 40 KB. Okay, you need to divide 40 KB with 4, and then you need to multiply it with the number of reads. In my case, like example 1, I have like 20 reads. So in that case, you can see 200 RCUs, read capacity units, are utilized. In the second example, we have like 5 reads, and per item size is 6 KB. So I divide it 8 divided by 4, because I need to round the data size to the nearest 4. So I will round 6 to 8, and then multiply it with 5. So I have 10 write capacity unit utilized here. In the next slide, we are like basically calculating the eventually consistent reads. So in this, again, like you have to round data up to nearest 4, divide the data by 4, multiply the number of reads, divide the final number by 2, round up to nearest whole number. You can see this in the eventually consistent read calculation. The final result, like wherever we have it, is divided by 2, because one strongly consistent read is consumed. Like if you have like eventually consistent read, then like there you can have like two eventually consistent read, and if you want to do strongly consistent read, then you can have like one. So how to calculate RCUs for eventually consistent read? You need to first, like as in the previous slide, like you need to round to the nearest 4, you need to divide the data size by 4, you need to multiply the number of reads, you can divide the final number by 2, because it is eventually consistent, so it is like 2 times of strongly consistent, and round up the data to nearest whole number. So you can see like we have like 20 reads, and then we have per item size is 40 KB, and then what we are doing is 40 divided by 4, then multiplying with the number of reads, it is 20, and then we divide it by 2, because it is eventually consistent. In case of strongly consistent, the divided by 2 part is not there, rest the formula is same. Now going to write capacity unit. So a write capacity unit is equivalent to one write operation per second for an item that is up to 1 KB in size. So how to calculate it? First of all, you have to round data up to the nearest whole number, multiply by the number of writes. For instance, in the first example, I have 20 write and per item size is 40 KB. So I will divide 40 multiplied by 20. So it is 800 write capacity units. In the second example, I have 78 write and the data per item size is 1 KB. So just like I will multiply 1 multiply by 78, the result is 78. So 78 write capacity units are consumed. In the third example, we have like 500 bytes. The data size is 500 and the write are 34, but we need to round it up to the nearest whole number. So in case of 500, we will round it up to 1. In case of 1.5 KB, we will round it up to 2. So this is why I have this third example. So and then I will just like do 34 multiplied by 1, and that is 34 write capacity units. And now we will discuss about the DynamoDB partitions. DynamoDB automatically splits the large tables into smaller chunks of data called partition to improve the read speed of the whole database. Partition occurs when the table exceeds 10 GB of data, or when the table exceeds 3000 read capacity unit, or if it exceeds 1000 write capacity units. In addition to, DynamoDB may split a partition if it detects a hot partition issue to try and eventually distribute the RCUs and WCUs across the partitions. So you can see in the picture that you have like different partitions. Generally, like the partitions are created based on the size. So you have like different partitions, each of 10 GB size, and then the DynamoDB is basically getting the data from different partitions and then serving to the client. And it, other than like 10 GB, you can like, it can be a case that you exceed like 3000 RCU or 1000 WCU. So it can be other cases as well. So this is how basically the DynamoDB partition works. And if I explain it to you, the partition formula, so you can see that the RCU, like how to find the number of partitions. What you have to do is you have to first on top write RCUs, the read capacity units, and divided by 3000 RCUs. Then you have to write write capacity units, and then divided by 1000 write capacity units, and then add them. So in case then you will get the value of total number of partitions. Like if in your case the RCUs for reads are like 6000, divided by 3000, it is basically 2. Okay, plus the write capacity units in your case are like 3000. 3000 divided by 1000, it is 3. So 2 plus 3, 5. So in terms of throughput, you need 5 different partitions, because it can be a case that your data is very small. It is not like it can be like 8 GB, but you are frequently reading the data and frequently writing the data and like then deleting it. So but you want to like read and write very frequently, so that in that case as well, you will have like multiple partitions of the data. In that case, like all the data is not read from one particular data node. The data is read from different data nodes, so there is no heavy processing on one particular node. So it is the first formula. This is for the throughput. The second is based on size. It is like very simple. The total size in GB divided by 10. Like if your total size is like 50 GB, then you divide it by 10. Then you have like 5. The number of partition should be 5. And then in the end, we have like number of partition equal to max partition for size or partition for throughput. You can calculate both, like the partition for throughput, what is that particular value, and then you can calculate like partition for size. For instance, like partition for throughput is 7, but partition for size is 3. So in the end, the formula is specifying you need to choose the larger number. Like in my case, I will not say okay, like my size is less, so my size is 30 GB, so my partition should be 3. But in terms of throughput, like if the number of partition is 7, so I will choose 7, and I will create 7 different partitions. So you have to be prepared, like and then your system works best. So moving forward to DynamoDB Streams, a DynamoDB stream provides a log of changes to a table similar to a transaction log. DynamoDB stream is a sequence of changes made to item in Amazon DynamoDB table. It can be activated to keep track of any modification to data items in a table. Your application must connect to DynamoDB stream endpoint and issue API request in order to read and process a stream. A stream records are organized into shards which act as a container for multiple record. Shards are ephemeral and can split into multiple new shards automatically. When a stream is disabled, any open shard will be closed and the data will remain readable for next 24 hours. It is important to process the parent shard before the child shard To ensure the stream records are in the correct order, DynamoDB Streams Kinesis adapter can handle this automatically. This feature is useful in a range of scenarios, such as when sending welcome message to a new customer or when updating messages or pictures in a group chat. An endpoint must be maintained for DynamoDB and DynamoDB streams to ensure the data is kept up to date. Moving forward to DynamoDB Accelerator. So it is also known as DAX, DAX. It is a fully managed in-memory caching system for DynamoDB that runs in a cluster to provide write-through caching. So basically, DynamoDB is like very fast database and it is very efficient, but there is an option. You can use DAX and make it even more faster. It has like a built-in uh, caching mechanism and it follows right through caching. Okay, so reads are eventually consistent. Okay, and then requests to the cluster are eventually distributed among its nodes. DAX can dramatically reduce the read response time to microseconds. Okay, in terms of write, the time will be same because it is write through caching. Write through caching mean that at the time of write, that cache is populated. So at the time of read, you get like data instantly. The read through caching basically mean that at the time of reading, the cache is populated, which is not the case in DAX. So we can have a separate video on like what are the different caching strategies, read through caching, write through caching. But in this scenario, DAX is using write through caching. And now we will discuss when to use DAX and when not to use DAX. Application that need like quick response can like configure DAX. Application that reads items very regularly, like again and again they're reading data, then DAX is a good options. And then in the end, apps that are very read intensive, like the overall nature of the app is very read intensive, not write intensive, then DAX is a good option for you. And when not to use a DAX, application that require strongly consistent reads, because in DAX it is stated above as well that it provides eventually consistent reads. So if your scenario is that you need like strongly consistent read, then DAX is not the case for you. Application that do not need a microsecond read response time, for like for instance in your application you need like a response time can be 500 millisecond or like 1 second, because DynamoDB like response time is very fast itself as well. So if you do not need like any microsecond response time, then DAX is not for you. And in write intensive application or those with minimal read activities, like if your application have like a lot of write or have like very few reads, then DAX is not the appropriate tool for you. If you do not need DAX, consider Elastic Cache as an alternative. Okay, and this brings us to an end of this DynamoDB fundamental. Now I will summarize all the things that we have discussed. DynamoDB is like a NoSQL based database technology created by Amazon for like high performance application. It replicates the data across three different availability zones and store three different copies. It is infinitely scalable and supports a variety of data types. DynamoDB offered two capacity modes, provisioned and on demand. In provisioned, you have to specify the number of reads and writes you are going to be doing. And in on-demand service, you do not need to specify. You have an upper threshold of 40,000 reads and 40,000 writes. And it has two types of indexes, like local secondary index and global secondary index. Local secondary index is basically you can specify that along the time when you're creating the table, it utilize all the settings and all of that of the table, like the capacity units are shared with the table. In global secondary index, you can specify after the table is created, you can modify them, delete them. Their capacity units are separate, not linked with the base table. And then DynamoDB also have streams. Whatever the changes are in DynamoDB, you can see them. And then you can also attach like kinesis and different services with that. And then DynamoDB Accelerator like DAX are available for specific workload in case you need caching. So this is like a quick overview of all the things that we have discussed. So if you like the video, then do hit the like button and subscribe my channel, and let me know in the comments that if you need to know more about DynamoDB. Thank you.